Okay, so where there's a crack, you're going to want to hold that joint in place. I just use some screws running through a metal plate and to stabilize the joint, just as you would do with any metal you'd weld. I also used, for the larger ones, I had some metal stakes and held the larger joints together that way. But whatever material you've got to hold the joint together, you're going to do that to stabilize it, because the material wants to move a little bit. Obviously, as you heat it, it will flex and bend and become more pliable and move out of place. So I went ahead and stabilized everything first, and then came back and welded between the joints, or between the patches, and then brought those together, then removed the metal and welded where those stabilizers were. And now I'm down to the point where I'm just going to be doing the last one, which I'll show you here. So you can see this joint. I'm going to use the heat gun to start at one edge, get all of it pretty warm, and then I'll come back with a 5-way tool and just kind of scratch at the joint and then hit it again with the heat gun, and that will allow me to get some deep penetration with the heat and make it more pliable. And then the final step is just to come back and smooth that material into place to make a good fusion. Michigan State has a good article on testing poly tanks to see if they're worth welding, and basically the easiest test is the baseball bat test. You just take a bat and hammer on the tank, and if it cracks, then obviously you don't have material that's worth fixing or holding on to. However, if you can beat on the tank and it'll take the impact, then you can know that you've got material that's still flexible and worth repairing. The other thing is a magic marker test. You can take a water-soluble magic marker, apply it to the surface, and if it wipes off, then it's good. Or if the other thing, you can see cracks that are in the tank with the magic marker. If it's permeable, then the tank's no good. Okay.